In this video, we're going to look at what the term gradient means and see how we can calculate it from a graph using three different methods. One where we find out how much the line has risen by for each one that it goes across a second that uses the rise of a run equation, and a third that uses the change in y over change in x equation. Although, as we'll see, these second two methods are basically the same thing. Now the gradient is basically just a measure of how steep a particular line is. So if we took these four hills, this first one in the top left has the highest gradient because it's increasing in height most quickly, or in other words, it's the steepest. Meanwhile, the second one is less steep and so has a lower gradient. The slope in the bottom left, though, isn't rising at all. It's completely flat. So this one has a gradient of 0 because it's not going up or down. And this last one is sloping downwards, so we say it has a negative gradient. And if it was sloping downwards even more steeply, then its gradient would be even more negative. If we show these lines properly on graphs instead, though, then we can actually calculate the gradient of each one. But for the sake of space, let's move them all over to the side for now and look at them one by one, starting with the first. As we mentioned at the beginning, there are a few different ways that we can find the gradients, but the most simple technique is just to figure out how much the line goes up by each time that it goes across by one. For example, if we pick any point along our line like this one here, and we draw little dashed lines going across by 1, and then up until we meet the line, we can see that for every one that it goes across to the right, it also goes up by 1, so the gradient of this line is 1, and would have found the same gradient no matter where we looked along our line. If we look at our next line, though, and do the same thing this time for every corner that it goes across, it only goes up by 0.5. And so the gradient of this line is only 0.5, which means it's less steep than our last line. Another way to think about the gradient is to use this equation here, which says that the gradient is equal to the rise divided by the run, with the rise being how much the line has gone up by, and the run being how much the line has gone across by. You might also have seen it as change in y divided by change in x, because the rise is basically how much the y value has changed by, and the run is just how much the x value has changed by. So these two equations are basically the same thing, which means you can use whichever one of them you want. So if we use the equation with our example here, we just figured out that it went up by 0.5, so our rise or change in y would be 0.5, and it went across by a 1, so that's our run or change in x, which means that our gradient would be 0.5 divided by 1, which is just 0.5, just like we got before. Importantly, though, we can also use this equation for longer stretches of our graph as well. For example, if we wanted to find the gradient between these 2 points, which are quite far apart, then we need to draw dashed lines between them by going across and then up, and then figure out exactly how much we want to cross and up by. So if we start with how much we want to cross, we went from x equals -4 all the way to where x equals 2, so our x value has increased by 6. Then, to figure out the rise, we went from where y equals -1 up to where y equals 2, which is an increase of 3. Then we can put these figures into our equation by doing the rise or change in y of 3 over the run or change in x of 6, which gives us 3 divided by 6, so 0.5 again. If we switch to our third graph, now this one doesn't rise at all, so no matter which points you pick along the line, the rise will always be 0, which means that our gradient will always be 0 as well. Moving on to our last graph, one thing to point out is that you always have to think of lines as traveling from left to right. So this line is going down and will therefore have a negative gradient. To find what that gradient is, we can use any of the techniques that we've looked at so far. The easiest one for simple graphs like this is to pick any point along the line, go across by 1, and then see how many you have to go up or down by. So, because we had to go down by 2, which is a change of -2, we know that the gradient must be -2 for this line. To use one of the equations instead, we pick any 2 points along the line and find the rise over run. So if we draw dashed lines between these two, we can see that it's gone down from 3 to -3 on the y-axis, so a change of -6, and along from -1 to 2 on the x-axis, so a change of 3. And if we then plug these values into our equation, we're going to get -6 divided by 3, which gives us a gradient of -2. Anyway, that's everything for this video, so hope it all made sense, and cheers for watching.